Do you ever stop and think about the magic that happens when you hit send? I mean, an email zips across the entire planet in seconds. A web page just appears. It really does feel like magic, but it's not. It's this incredibly elegant system, a hidden rulebook that makes our whole digital world possible. So today, we're going to pull back that curtain and take a look at the rulebook.
But seriously, how does that actually work? How does a message from your laptop in London find its way perfectly to a server in Tokyo? It has to navigate this insane maze of routers and cables and satellites. It's not magic. It is an absolute masterpiece of engineering and standardization.
You know, the best way to wrap your head around it is to think of a postal service. The post office has a really clear system, right? You've got addresses, zip codes, sorting facilities, delivery trucks. The internet needs that exact same kind of structure. Without a universal set of rules, sending even one tiny bit of data would be absolute chaos.
Well, that rulebook has a name, the OSI model. It stands for Open Systems Interconnection. It's basically the ultimate blueprint, and it was created way back in the 70s with this simple but totally revolutionary goal: to let any two computers from any manufacturer anywhere on Earth talk to each other.
And here's the brilliant part. Instead of trying to solve this giant problem all at once, the OSI model breaks the entire process of communication down into 7 distinct manageable layers. Each layer has one specific job to do, and it only has to worry about the layers directly above and below it. Simple, right?
So here they are, all 7 layers. When you send something, your data travels down this stack, and it's like it gets wrapped in a new set of instructions at every single step. And when you receive something, that data travels back up the stack, unwrapping those instructions until the original message is revealed. It's a pretty incredible journey. Now, I know what you're thinking. How am I going to remember all these in order? Don't worry, we've got you. Here's a classic mnemonic to help you remember them from the bottom up. From layer 1 to 7, please do not touch Steve's pet alligator. That's physical, data link, network, transport, session, presentation, and application. Got it? Awesome.
All right, let's start this journey, where you, the user, actually live, right at the very top of the stack. These first 3 layers are all about your software and getting your data ready for its big trip.
This is the layer you actually see and interact with. It's your web browser, your email client, your messaging app. It provides the services that let you do things like send files or browse the web. Basically, if you can click on it, it's probably living here at the application layer.
So, different computers can format data in totally different ways. The presentation layer acts like a universal translator. It takes your data and converts it into a standard format that any machine on the other end can understand. And it also handles a couple of other crucial jobs, like encryption to keep your data safe, and compression to make it smaller so it travels faster.
Think of this layer as the conversation's traffic cop. It sets up the connection between 2 devices, it keeps that conversation going, and then it ends it when everything's done. But it has this really clever trick up its sleeve: checkpoints. Imagine you're downloading a huge file and the connection drops halfway through. Ugh, the worst. Well, this layer inserts checkpoints, so you can just pick up right where you left off instead of starting all over again. It's a lifesaver.
Okay, so our data is translated, it's secure, and the conversation is all set up. Now we get to the really nitty-gritty part. We move down to the lower 4 layers, and their job is to handle the logistics of actually moving all that data across the network.
I like to think of this layer as the quality control manager. It takes that big chunk of data from the upper layers and chops it into smaller, numbered pieces. Its main job is to make sure every single one of those pieces gets from the right app on the sending computer, say your browser, to the right app on the receiving computer, the web server, and that they all arrive in one piece and in the right order.
And it does this in a few key ways. First, it does the chopping up and then reassembles it on the other end. It also controls the flow, so a super-fast sender doesn't overwhelm a slower receiver. And, most importantly, it checks for errors. If a piece gets lost or damaged on the way, this is the layer that raises its hand and says, "Hey, can you send that one again?"
And those little numbered pieces we've been talking about, well, they get their first official name on this journey. They're now called segments. Our data is starting to get its travel documents in order.
Next up is the network layer, and this one acts like a global GPS for your data. Its whole job is to look at the entire internet and figure out the best possible route to get from the source to the final destination. And it does this using what are called logical addresses, which you probably know as IP addresses. It's the unique street address for every device on the global network.
To make this happen,
The network layer takes each segment and wraps it in a new header. This header contains the source and destination IP addresses, basically the mailing label for the whole trip. And just like that, our segment has leveled up. It's now officially called a packet.
So, if the network layer planned the entire cross-country road trip, the data link layer is responsible for driving each individual leg of that journey. It handles the local hop-to-hop delivery, getting the data safely from your computer to your home router, and then from your router to the next one in the chain, and so on. So how does it handle a local trip? Well, it takes our packet and wraps it up again, this time with the physical MAC addresses of the current device and the very next device it needs to go to. A MAC address is like a unique serial number that's burned into the hardware. And this newly wrapped data gets a new name too. It's now called a frame. We're almost at the finish line.
And here we are, at the bottom. This is where the rubber literally meets the road. The physical layer takes those neatly organized frames and turns them into the actual ones and zeros, the bits, that are going to travel over a physical medium. We're talking electrical signals flowing through a copper cable, pulses of light in a fiber optic line, or radio waves flying through the air. This is data in motion.
So, our data has made it all the way down the stack and is now flying across the world as raw bits. You might be thinking, wow, that's a lot of steps. Why all this trouble with 7 separate layers? Well, it turns out this layered approach is what makes the whole thing so incredibly powerful.
There are 3 huge reasons. First, interoperability. It's why your iPhone can talk to a Windows server without a problem. Second, flexibility. When a new technology like, say, 5G comes along, engineers only have to update the bottom few layers. Your apps, like Netflix and Gmail, don't have to change at all. And third, it makes fixing problems so much easier. Can't connect? Check the cable. That's a layer 1 problem. Can't load a website? Maybe it's a wrong address. That's a layer 3 problem. It's brilliant.
And here it is, the whole journey in one single view. From your application at the top, your data gets prepared, segmented, addressed, framed, and finally blasted out as bits. And on the other side of the world, that exact same process happens in perfect reverse, with each layer unwrapping its part of the puzzle until your original data appears, totally pristine, on the other screen.
But here's the thing that just blows my mind. This entire blueprint was designed in the 1970s. That was way before we had streaming video or cloud computing or smartphones. The fact that this same fundamental model is still powering our hyper-connected world today isn't an accident. It is a testament to the absolute genius of its design. Thanks for coming on this journey down the stack with us.